Page 305, question number 11. An ideal spring with an elastic constant of 2,000 newtons per meter is compressed a distance of 0.400 meters. So when they talk about an ideal spring, it simply means that it won't lose any energy as you compress and release it. So how much elastic potential energy does this compression store in the spring? So our spring energy is kx squared divided by 2. Our K value is given as 2,000 newtons per meter. Our X value is given as 0.400 meters. So plugging that into our calculator, 2,000 times 0.4 squared divided by 2 tells us we have 160 joules of energy stored in our spring. Part B, if this spring transfers all of its elastic potential energy into kinetic energy of a 2 kilogram mass, what speed would that mass have? Assume the initial speed of the mass is equal to 0. So all of this is going to be converted into kinetic energy. So our kinetic energy is equal to mv squared divided by 2. We're looking for the velocity, so we multiply by 2, divide by the mass and square root. So V equals the square root 2 times our energy divided by the mass. So we end up with the square root of 2 times 160 joules divided by our mass, which is 2.00 kilograms. Square root of 2 times 160 divided by 2, and that gives us 12.64911064 meters per second. So that will be 12.6 meters per second as the velocity of the mass when it leaves the spring.